Hello chemistry students, welcome to this little video on how to do electron configurations. Not very difficult. It can seem kind of daunting, but it's just not. And so first of all, what is the idea of electron configurations? Well, the idea is, so you've got a nucleus. Let's go ahead and turn on this one. You've got a nucleus in the middle of an atom, right? And then around that atom are electrons, and they're whizzing around that atom. And those electrons exist in different energy levels. Within those energy levels are sublevels, and within those sublevels are orbitals. So the whole idea of electron configurations is sort of assigning locations and defining where all the electrons in a particular atom are. So for example, if we look at an atom like sodium, so sodium has 11 protons, right? So it's got 11 positive charges in the nucleus. So that means that around it, it has 11 electrons it will naturally have, so it can cancel out. And so what happens is those electrons exist in energy levels. So first of all, we could say that this is energy level number 1. We'll start at energy level number 1. Now in energy level number 1, you have one sublevel, which is the S sublevel. And each sublevel can have orbitals. Now S only has one orbital. So I'll just draw this up here. So S has one orbital, and each orbital has two. Let's draw this. So this is the orbital. This is the sublevel. Okay. And each orbital has 2 electrons. So that would give S a total of 2 electrons, right? Because it has one orbital. All right, in energy level number 2, so that's 1, and so we can have the 1s right there. So sodium has 2 electrons there, so we go 1s2, saying we're in energy level number 1, s, and then 2 electrons, okay? And so we need to get up to 11, so that's only 2. So the energy level number 2 is beyond that. And so now that we're in 2, we also have sublevel S. Everything starts with sublevel S. And so sublevel S has another 2 electrons. So this one is going to have another 2. So that's a total of 4. All right. Now, in energy level 2, you can also have sublevel P. Sublevel P has a total of 3 orbitals. Remember, each orbital contains 2 electrons possible. So that's going to give it a total of 6 electrons. All right, now p orbitals kind of look like this. Here's what I'm going to do. Actually, I'm going to go ahead and change the color of this s orbital so that, or this this energy level number 2 orbital right here. All right, so here you go. So this is energy level number 2, 2s, and so there's 2 electrons right there. Now it also has p's. Now p's kind of make a figure 8. So there's 1, 2, 3. Now each of these has 2 electrons, so I drew 3 of them. So I'd have 2 electrons here, 2 electrons here, and 2 electrons here, whizzing around in these. And these are the 2p's. So what we'll say is we'll have 2p and a total of 6. Okay? So that's 2p6. So remember, sodium has 11 electrons. So far we have energy level number 1, sublevel S, and there's 2. Energy level number 2 has sublevel S, and there's 2. And then energy level number 2, sublevel P, has 6. And so we still have 1 more electron left to go, because that's a total of 10 electrons. And so we're going to go up to energy level number 3. So energy level number 3 will have sublevel S, sublevel P, and sublevel D. So Ds have a total of 5 orbitals, which give them an ability to hold 10 electrons. Because remember, each orbital can hold 2 electrons. Sublevel S only has 1 orbital, P has 3, D has 5. Now, for the case of sodium, all we need to do is put 1 electron in this 3s, because that'll give it its total of 11. So we have 2 here, plus another 2 here, that's 4, plus 6 here is 10, plus 1 more here is going to be my, my 11th. All right. Now that might seem confusing to you, but the whole idea is this is where the 11 electrons are, and this is how they fill in order, starting from 1s and going up. All right. Energy level number 4 then has S, P, D, and the last sublevel called F, and F has a total of 7 orbitals, and that's 14 electrons. So And then once you get past that, it's the same. They only go up to sublevel F. All right, so let me show you a way to use the periodic table in order to figure this out. So in your typical periodic table, it looks like this. The way that this is set up is so that you can use this to figure out the electron configurations of any atom. Okay, so the first thing we're going to do is we're going to take and we're going to say each one of these periods going from left to right represents an energy level. So I have energy level number 1, number 2, number 3, number 4, number 5, number 6, number 7. All right, so as we go along here, all these atoms, their outermost electrons can't go past energy level number 1. And all of these, they keep all of their electrons in energy levels number 1 and 2. It can't go past 2. And here we can get up to 3, but not past. Here, 4. Now, when we get to this section, it's off 1. And this is important. So when this is 4, then this is 3. And you're probably thinking, I don't know what's happening right now. So just to... why don't I just go ahead and erase this so that I don't confuse you there. Okay, so let's just say these are the energy levels 1, 2, and a lot of periodic tables are labeled 1, 2, 3, 4, 5, 6, 7 to show the energy levels. All right, now this is important. You notice that there's these geometric boxes, and I just boxed this one, and then we have another kind of geometric shape here, and then another geometric shape here. This helium should go right here. So we could say helium. For our purposes right here, helium exists over here because it's a noble gas. But for electron configurations, it's really right here. Now, this box right here represents the S sublevel. And notice that in the S sublevel, we said previously, right? We said previously that it had only 1 orbital. And so it holds a total of 2 electrons. So what you'll notice is that this has 2 columns, 2 boxes representing each of the 2 electrons in the s orbital. So just remember that. That's the s orbital box. And this will all make sense as we come together and we start working on it. This represents d orbitals. All the electrons in this group have their final electrons in d orbitals. So this geometric box in the middle represents d orbitals. Now, the d orbitals are shifted 1 energy level off, and that's why I wrote that before. So when this S is 4, the D is 3. When this is 5, this is 4, and so you need to remember that. The reason for that is because it takes more energy to fill a D than it does to go up a level and fill an S, so they're sort of lagging behind. But just remember, all you got to remember is that when you get to this, it's shifted off 1 number. All right. And so then finally over here, well actually not finally, and then this big block, and notice this is a different kind of block, this represents the P sublevels. And so notice the D, if we go back to our original thing, we said the D orbitals have a total of 10 electrons, right? And so you'll notice 10 boxes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then P has a total of 6 electrons. You'll notice 6 boxes, 1, 2, 3, 4, 5, 6. Okay? And then down here below, this is going to be the F orbitals. All right. So let's go ahead and do something here. Let's go ahead and I am going to show you how to do an electron configuration. Okay, oops, that was the wrong one. Let's see, there we go. I'm going to show you how to do an electron configuration using this method right here. All right, and it's not very difficult. Let's go ahead and get red. That'll be fun. All right. So now that you know that these are energy levels going left to right, and you know that each of these boxes represents the sublevels, you can figure out the electron configuration of any atom on the periodic table. So let's go ahead and start with a simple one. Let's look at let's go right over here. Let's look at chlorine. Chlorine has a total of 17 electrons. So here's what we need to do. We need to figure out where those 17 electrons are, in what orbitals, and in what sublevels, okay? Energy levels and sublevels. So here's how we do it. We start from the top, and this is energy level number 1. So that's where I start. I'm at energy level number 1, and this is block S, so that's going to be sublevel S. That's what I hit first, and I'm going to count my boxes here, and I'm just going to keep going until I get to chlorine. So if I count, I go 1, 2, and there's nothing else up here. So that signifies 2 electrons. So energy level number 1, sublevel S, 2 electrons. Now I'm going to go back down. Here I'm at 2. So 2, and this is also the S block. And so I'm at 2, I hit the S block, and this is going to be 2 boxes. I'm going to pass both boxes, 1, 2. And so as you pass boxes, that's where you put these little numbers up here. And I'm going to go straight across, and I'm going to hit this. Well, this is energy level number 2, right? And now, though, I've hit P. This is my P block. So energy level number 2 still. And I hit P. And how many boxes do I pass? Well, I pass all of them. 1, 2, 3, 4, 5, 6. So remember, I need to get down here to chlorine, right? This is my final destination down here. So I pass all 6. So I'm going to put that 6 up there. And I'm going to keep going. And you just keep going until you get to the atom that you want. And now I'm at 3. So I'm going to put 3 up here. And this is S. So I hit the S again. I'm going to pass both blocks, 1, 2. So I'll put that 2 there. And I'm going to go straight across. And there's 3P. Now, to get to chlorine, though, so I have 3P, you get to chlorine, I'm not going to pass all 6 boxes. So how many am I going to get? 1, 2, 3, 4, 5. There I am. I'm at 3P, and I only get 5. Now, if you count up the total amount of electrons, each of these exponents stands for electrons, you should have 17. So we have 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 5 is 17. There you go. There's the electron configuration for chlorine. Let's go ahead and do one that is a little bit more difficult. Let's go ahead and pick, how about Cobalt here? Okay, so here's Cobalt. So we want to end at Cobalt. 27 electrons. So we start up at the top. Here's energy level number 1. You always start there. 1s, 2. Okay, because we passed both boxes. Now I'm going to go down. 2. And this is block S. Pass both boxes. 2s, 2. Get here. Now I'm at 2. Energy level number 2. And I'm at P. So 2P. Pass all of those. So that's 6. Go down here to energy level number 3. 3, this is block S, pass both of those, so 3s2. Hit here, now I'm at 3p6. I'm going to pass all of those, 3p6. Go back down here, I'm at 4s. So this is 4s and 2, because I'm going to pass both of those. Now remember, when I get to this block, this is the D block, remember this is shifted off one number. So if this is 4, this is going to be 3. So I have 3D. And how many do I have? 1, 2, 3, 4, 5, 6, 7. 3D7, because that's sitting in the 7th spot on the 3D. And now let's see, we need 27. So we got 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, plus 2 is 20, plus 7 is 27. There we go. Those are all the electrons. Those are in their correct orbitals and in their correct sublevels. Now, just for fun, let's go ahead and do one that's down here. When you get down here, this is going to be shifted off 2. And this F actually inserts itself right here. So once you get here, you have to start counting Fs, and they're shifted off 4. All right, so let's do one that is past all that. Let's do PO, PO, polonium right here. So you see PO. Okay, so we're going to do the electron configuration for PO. It's going to have 84 electrons total. So we're going to fill up this whole sheet here. Let's go ahead and just do it down here. We'll start all the way over here. So I have 1s2. That's what I'm going to start with. So 1s2, 2s2, because I go 1s2 and back down here 2s2, and then I'm 2p6. 2p6, and then 3s2. Here's where I'm at right here. So I got all 6. 3s2, 3p6, because I hit this one right here. Now I'm at 4s2. So 4s2. Now I hit 3d10, because I got all of those. 3d10, and now I'm back to energy level number 4 in the P, because only this one shifted off one, not this one. This one stays with the numbers here. So I have 4p, and I get all 6 of those. So 4p6, now I'm back down to here. Now I have 5s2, 5s2, right? And now I'm going to go down to 4d10. So 4d10, because that shifted off one. Now I'm right here. This is going to be 5p6, 5p6. Now I'm back over here to 6s2, 6s2. Now what happens is I have to go and do this run, because this one inserts itself here and it's shifted off 2. So this is going to be energy level number 4. This is sublevel F, and I'm going to get all 14 of those boxes, sublevel F14. Okay, now I'm picked back up where I am right here. So I'm back here at the D right here. Remember, the D is shifted off 1. So if this is 6, this one's going to be 5. So I have 5D, and I'm going to get all those, 5D10. And then I finally get over here, and I'm almost to my destination. And so this one matches up to this. So that's going to be 6P, 1, 2, 3, 4. 6P4. Okay, we needed 84 electrons, so let's see if we got them. We got 2 plus 2 is 4, plus 6 is 10, plus 2 is 18, plus 2 is 12, plus 6 is 18, plus 2 is 20, plus 10 is 30, plus 6 is 36, 38, 48, 54, 56, plus 14 is 70, plus 10 is 84. There we are, 84. Yep, yay, we got it. So those are all of the electrons that are in the correct places and the correct sublevels, and we've got them all defined. So hopefully this helps you to do your electron configurations as you are asked to do them for your chemistry class.